Hi everybody, my name is Taufeeq Dhansay from the Council for Geoscience South Africa, and today I'm going to tell you a bit about our program that is focusing on integrated and multidisciplinary types of geosciences and how we're using this program to look towards minerals of the future and actually contributing towards the social and economic development of the country. So to start with, I will give you a bit of a background. The premise of the story really is that South Africa has a very long-standing mining and minerals industry. These industries has contributed towards the country's social and economic development in the past. In fact, it's really the key driver of our industrialization. However, in the last several decades, we've seen that its contribution has decreased drastically. Associated with that, we also see that the country's levels of inequality and poverty have increased. So we see that these industries are very probably linked. In a country like South Africa that has relied heavily on the mining industry, we need it really to be a key driver and contributor of our development imperatives. So to do this, the South African government has now targeted attracting about 5 to 10% of the global exploration share. The way we're going to do this is through geoscience, data, information, and knowledge. We want to use this geoscience to truly show the value of South Africa's geology towards possible mineral resources, such as critical minerals, and hope to use it as a driver to stimulate other industries, such as the downstream beneficiation system of these various mineral resources, and also other applications towards generally the associated industries. So critical minerals in South Africa is not actually a new thing. In the past, lots of the mining in a country like South Africa that has been mining for many years, we've actually mined some of these minerals, historically. However, the industry was not available to actually really use these mineral resources. So in many cases, there is historical evidence to suggest that we have been mining those minerals, but because the global economics was not maybe conducive, we never really produced this. So critical minerals in South Africa is not a new thing. Now we see that the industry locally has caught up, and this is a big change right now. So in South Africa, we are moving towards things such as hydrogen fuel cells that needs to rely a lot on PGEs, of course, because of the lithium and the vanadium that we have in South Africa. There's a big move towards battery minerals. So both types, as these batteries have different applications, lithium-ion batteries has a big industry, and right now vanadium redox flow batteries as well, a huge industry. More so than that, there's also various medical applications. So South Africa has a lot of potentially radiogenic materials that can be used in various medical sectors, especially with regards to oncology. In addition to that, we really now want to move towards the manufacturing and the refining side of these mineral sources. So in the past, South Africa was a raw producer. We want to move that one step further where we actually produce some level of first-degree beneficiation, perhaps second-degree beneficiation. And secondly, produce those type of downstream industries that can actually take it to the next step. So that really is the industry that we're looking at right now. Now, the Council for Geoscience is the geological survey, previously the geological survey of the country. We are a government-mandated body that is responsible for finding geoscience solutions to drive national development. So South Africa has a national development plan that is linked very closely to the World Sustainable Development Goals. This, of course, means to increase the quality of living for human, social, and economic development, decreasing poverty, ending hunger, all of those kind of things. Where we come in with this is that we feel that geoscience in South Africa can be a key driver of national development. By producing these type of geoscience data sets, we can show various aspects of our country that can be developed to actually contribute towards this. So the Council for Geoscience has designed 5 key themes that's looking towards this. One of the biggest themes is the minerals and energy themes. We're also looking at water and environment, land use and infrastructure. We do a bit of diplomatic work in SADC and other African countries. And of course, we're trying to be very innovative. These are the 5 themes that we're using towards this. So when we look at the geology of South Africa, to give you an idea, South Africa's geology is very world-renowned in terms of its, number one, the heterogeneity of the rocks. You can find various different types of sequences, different geological terrains. But importantly, we also have large mineral resources. So here on the right, you can see that here's the Merensky Reef. South Africa has several hundreds, if not thousands of years worth of PGM reserves combined. And, so to speak, we're only scratching the surface with regards to the Bushveld complex and PGEs. So South Africa has and continues to actually lead in many different types of mineral resources. And this is, of course, is largely linked to the geology of the country. South Africa is mapped onto a 250,000 scale, 1:250,000 scale. And these maps have actually highlighted many of these mineral resources. And through that process, there's been a lot of the mining and minerals development industries. Right now, we do not have 50,000 scale maps, and this is one of the biggest issues that we're facing right now. So when we look at the geology of South Africa, it has to some extent stagnated with regards to the data we have been releasing. So now we're trying to go back and actually relook at the geology in higher detail using more innovative techniques. We already know that South Africa has a lot of primary sedimentary, hydrothermal, magmatic systems. But when we actually start looking at it on a higher resolution of 50,000 scale, we actually see that many of these systems are more complex, number one. They're more widespread than what we had previously thought. And this actually will then contribute towards increasing the minerals industry. So when we look at the geology of South Africa, it's very well mapped on a high resolution. So I'll quickly run through this. We have very old rocks. Our craton is around this area, the northeast part of the country. We see some of these old rocks. These are greenstone belts. There's quite several significant greenstone belts that we have in South Africa. These are very closely surrounded by various TTG, GGM sequences, tonalite gneisses, granite gneisses. The combination of the greenstones plus the gneisses actually enabled lots of hydrothermal systems. So there's a lot of mineral development in all of our greenstone belts. We also have some Archean sedimentary basins. Here's the Wits. The yellow is the outcropping portion of the Wit-Waterstrand supergroup. We have the Pongola supergroup. These are world-renowned gold producers, of course. You have the Ventersdorp large igneous province. These green rocks over here that has intruded into the sedimentary rocks. That has driven many hydrothermal systems, remobilized gold. Overlying that, you have the Transvaal and the Griqualand West supergroups. These are these blue sequences here. This is a very big basin deposit, and in its own right has lots of sedimentary hosted iron, manganese as well as and remobilized systems. Then we have our Meso to Neoproterozoic orogenic belt, which is the Namakwa Natal belt. It's the red. It continues all the way under these Karoo rocks, the official rocks. This is a very, very big target area in South Africa right now. It's a very wide zone that have lots of mineral potential, as do most of our Kibaran belts globally. Interesting enough, this is covered by lots of sand. So again, here we are just scratching the surface. In terms of our Karoo rocks, there's a lot of uranium, molybdenum, which is also quite important. So yeah, the geology of South Africa, well mapped on a big scale. Lots of information still needed on a smaller scale. Constantly, as we are mapping, we're actually finding various extensions of this geology. So linked back to the mining, what do we see? The message here, I think, is that several decades ago, and even going beyond this graph starts at 2000, but even further back than 2000, mining was a key contributor largely because of the availability of geoscience data. We had enough geoscience data to direct the industry in terms of where the next big mineral deposits were. We've all but exhausted that in terms of the maps are available, people are aware of that. What they're not aware of is the new data. And we know that mining can be a very big contributor. Right now, it's one of the biggest contributors still to the GDP, but you can see it's dropping. And this doesn't match the geology. We still have these minerals. We know this, large reserves of many, many mineral resources. So we really want to get those numbers up. That is the key driver of our program right now. When we look at critical minerals, I'm going to run through some of these just to give you an idea. Antimony, it's a very important mineral. We've accepted now that it's going to be used as a cathode material in many batteries. Probably in the last 3 or 4 years has been growing in importance. So we've seen that we have a lot of antimony in some of our greenstone belts. We do produce several million tons of antimony as well. And we accept that, it's going to be important. Of course, we've also now seen in terms of our mapping program that we're extending these deposits. This is largely because we find that the key structural controls on the greenstone belt, number one, we've remapped them. So we can see extensions. Number two, we've also extended some of these greenstone belts itself. So we're looking to double these deposits very soon. Cobalt is also quite important. Lots of cobalt is currently produced by the bushveld itself. So we find a lot of cobalt in the chromatite layers. Again, million tons being produced. Again, very important with regards to batteries. So we see a further strategic importance. In our program, we've also identified additional cobalt deposits in various nickel sulfides, in fact. So our geochem program becomes very important. Copper, lead, zinc, base metals is quite big in South Africa. You can see here that these Mesoproterozoic, the Namakwa belt, is quite important with regards to copper, lead, zinc deposits, all three. Lots of hydrothermal systems around the bushveld that's also driving these, especially zinc deposits. And again, up in the greenstones and even in the northern part of South Africa. So this is a very, very big resource in South Africa. You can see the numbers are quite large. In terms of iron and manganese, this is another big one. So in our these rocks, the chemical sedimentary rocks in the Griqualand West Basin, large volumes of iron and manganese. One of the biggest mining industries right now in this northern part of the country. There's lots of iron in banded iron formations as well in this part, and also we have remobilized manganese even here in the south, in the Cape Fold belt, this Paleozoic fold and thrust belt. Again, new deposits constantly being found. Manganese used to be mined quite significantly in the country in the past. The quality was not good for steel, but we are exploring this as a possible battery material as well. Lithium, very big deposits. We have extensive pegmatites in the country, so there's large pegmatites in this area, and there's quite a lot of pegmatites up here in the northern part of the country. These we believe are going to host significant lithium deposits. We really want to focus on these deposits very closely with the battery industry. Nickel as well. South Africa is quite a large producer of nickel. One of our biggest nickel mines is associated to the Bushveld complex and extension of the Bushveld complex. We're seeing more of these satellite bodies in our mapping program, so we're extending this constantly. Again, we know nickel is going to be continuously important with regards to the battery industry, so we focus on this quite significantly. PGEs, of course, we don't have to talk too much about this. South Africa has a lot of PGEs, especially now with regards to the electric market. We accept that PGEs are probably still going to be quite an important source. Locally, we're trying to beneficiate this a bit more with the fuel cell industry, so this becomes quite important. REEs, another big one. South Africa has lots of REEs, again in the Namakwa area, closely linked with the lithium in the pegmatites, lots of REEs in the bushveld. This map is going to change significantly very soon. The upper sequences of the bushveld, the felsic or the acidic rocks, have lots of REEs. So that's going to be quite important. Some of the highest grades as well, I should mention, these kind of secondary REEs that you're finding around this southern part of the Namakwaland. Titanium and vanadium, again, very important. Vanadium, big in the bushveld. It's really driving the vanadium redox flow battery industry. We have lots of titanium. So these are the sands that's coming, basically weathering off from some of these plutonic rocks close to the shore. So these are easy to be mined. You know, these heavy sands we're finding as well. We accept that these are also going to be quite important going forward. Final one, uranium and molybdenum. South Africa is the largest producer of Moly-99, which is very important in the medical industry. We're really looking at pushing this up. So we actually are beneficiating this, which is quite good. So we take uranium and we are able to beneficiate that into Moly-99. So this is an industry as well that really needs to grow. I think it's quite important, especially now with the medical advances. So in terms of our integrated mapping program, that kind of gives you an overview of the critical mineral resources. Now I'm just going to show you some highlights of this program. The way we've designed the program is that we've identified key areas around the country that we were mapping. So there's a mapping area here in the south. This is in the Karoo. We're looking particularly at the petrochemical side of things. So there's large volumes of shale gas, natural gas over here in the black shales that you're finding in this Karoo basin. So we do a mapping project around there. We're looking at a big mapping area around here, particularly with regards to the water and environmental side and also land use and infrastructure. But also there's also various other smaller mineral deposits that contribute to the aggregate development. Of course, we're mapping in the Namakwa belt, lots of critical minerals we're looking at there. We're looking at this area here where there's lots of iron and manganese and also hydrothermal deposits, particularly in the central KZN area. This is the extension of the Namakwa belt, the Natal sector. And of course, most of the northern part of South Africa, knowing that this is one of the key drivers of minerals and energy development. So this is how we've developed the program. I should also mention here that we also do some offshore mapping. So this is the South African exclusive economic zone offshore. So we do lots of offshore work trying to understand some of these offshore mineral development as well. So some of the highlights that I want to show you, here's an example from the Bushveld complex. So here we take various data sets such as geochem, multispectral remote sensing data, and high resolution geoscience mapping. And we are actually able to look at IOCG type deposits, so tin, fluorite, REE deposits. So this is looking at the acidic rocks in the Bushveld complex. Some of our my colleagues there in the Council for Geoscience that has worked on this work. We can see here that these points highlight the known occurrences. And based on our mapping and our integration, we actually see that we have much more potential. You can see there's quite a good correlation wherever potential has been mapped. Indeed, there's some development, and there's a lot more development. So what we're doing now is we're going into these areas, trying to map in a bit more higher resolution, produce the 50,000 maps, and we want to release those maps. So really driving this kind of development for these IOCG type deposits. Fluorite is, of course, also important for our own agricultural industry. Another big one is our lithium. So the pegmatite belt is a nice photo of the pegmatites. This is what you see, big, expansive pegmatites, several thousand square kilometers of pegmatites that we're finding. It was never mapped to high detail. So we have another of our colleagues, Mr. Doggard, that's actually been mapping in this area. And one of the key things that has come out of this program is that our knowledge of the pegmatite belt has increased about almost threefold. So far, we've actually increased the pegmatite belt on surface by about 70%. That is purely through the mapping. We've also extended the pegmatite belt subsurface based on available bore data. We've also been able to characterize it in terms of its type, whether it's NYF or LCT type pegmatites. We see that the LCT type pegmatites are very prospective with regards to lithium. Here's an example, some big spodumene crystals. And here's an example of some of the hyperspectral data we're using. So you can kind of see that the hyperspectral data has been excellent in terms of picking up the pegmatites. We're also now working out the key controls on the pegmatites, which is quite important. We see that they're structure controlled. We are able to work at the tectonic evolution and the geodynamic development of this area, and also how that has controlled the pegmatites. Importantly as well is because we know this continues, we've also seen very similar type of pegmatites in this sector across the country. So this is very important. So as the lithium industry and the lithium battery industry in particular grows, this work will become very, very critical. To give an idea of some of the data integration within the KZN area, so this part, the Natal sector, the premise here is that we know this has much more mineral potential than what is currently being mined. And here's an example. Here's a classical map, one of the old 50,000 maps that was produced. And as soon as we start integrating something like simple radiometric geophysics image, you can kind of see that it picks up very particular or peculiar signatures. We find that there's some big cyanide complex that hosts significant REEs that had not been mapped previously. You can kind of see, you might just be able to make out there were little prospects in the past. So now we've extended some of these deposits, also very, very important. So these maps will be released and it will hopefully drive the REE industry. More so something in the Cape. Here's an example from, again, one of our colleagues. We've remapped the Cape, especially with regards to the structures. We now see that manganese is critically controlled along some of these structures. And in fact, just on the side, it's not just manganese, but also groundwater. So we're now able to do the structural mapping in 3D. We then apply various fuzzy logic type of models, AI techniques, and we actually work out manganese potential. This is being also cross-referenced with further geological investigations. So we see there's a lot of potential there. So in summary, what have we seen so far? South Africa as a whole is covered by less than 20% of 50,000 maps. The current 50,000 maps that we are seeing right now is actually driving potential industries very effectively. In the 10%, as it were, of 50,000 maps that we've produced thus far, each map has either extended a known mineral deposit or identified a new mineral deposit. This is very important. We now know this data has to get out there, it has to be packaged effectively with regards to a sustainable development goal in terms of making sure that this data makes it to possible users that will actually contribute towards this global share of exploration in South Africa. So that is very, very important. We also see that in terms of these areas, South Africa is very important with regards to critical mineral resources. The more we map and the more we look at existing deposits, we actually see that the volumes, the estimates of critical minerals in South Africa has to be recalculated because there's quite a lot. In conclusion, here's an image showing the maps that we have in South Africa. You can see that quite a lot has been completed. we're focusing on these areas where we expect there to be critical mineral resources. We are now targeting that in the next 10 years, we are going to expand on this mapping program as fast as possible, look at more integrative techniques, and we really want to use this mapping program and the data that's being developed from this to contribute towards not only our local development, but also the larger global development of these critical mineral resources and these new industries that are contributing towards a broader sustainable development. Thank you very much.